我来share一下 screen。我们就还用英文，然后讨论的时候用中文就可以，这当时写下。
都可以。
Okay. Thanks for everyone coming. We for the group 2, we built a document chatbot based on ERCOT Nodal documentations. ERCOT is electricity reliability council of Texas, which is Jennifer's company. All those documents are from public domain, so it's publicly available to everyone to see. We have Lu, Junhao, Jin, Jia, and me. Let's go next. For today's agenda, Jennifer is gonna give the introduction, and Jen will deep dive in the text processing we use on the PDF documents, and Junhao and Lu will give the RAG architecture. Then Jie is not here. Either Jennifer or me can give the evaluation on the RAG's results. Then we can give a demo. Jennifer, you can.
Thanks for the introduction, Guofeng. So according to what we show here, that we are a company that is regulated by Texas state government. And our company is an independent system operator. And that company is something that is a company that to maintain the great reliability and to make sure that the electricity generated can be delivered to the place that it's needed. So that is something that about the background of our company, and it's a non-profit company. So the function of our company lies in two aspects. The first of all is it maintains the reliability of the grid. That means that it's balanced the supply and demand of the electricity. And that's the aspect of grid operation. On the other hand, we also maintain and operate a fully competitive energy trading market, and where we make sure that the money get paid to the party that generate the electricity, and the one that who use the electricity is paid the right amount of money that they need to pay. So that is the business of our company. And because I work in the markets department, so in the following we're going to focusing on the market aspect. So Guofeng, would you next page? So as you can see that according to my introduction, the electricity market operation is a domain-specific area. And for each ISO and RDO, we need to publish the nodal documentation to make sure that the market mechanism is transparency to the public. And moreover, in order to make sure that our market operation is accountable, so we need to publish those nodal documentation, and in a format that is fits in the regulation requirements. And also it makes we need to make sure that those documents are accessible to the public, so that it provides market guidance and pricing model and operation procedures for the market participants, so that they know that how they can trade their electricity in this market. And so that is the motivation that we would like to leverage those nodal documentation to build a chatbot, and so that people can easily access the information over there. And why that is hard for people to read or to understand those documentation. First of all, is because it's a because of the technical complexity. That means that there are a lot of specific terminology and that is hard to understand for the general audience of this documentation. And the other thing is about the formal and dense regulatory format, and in order to avoid any possible compliance issue, and that makes the documents when we draft those documents, we just sacrifice some understand some aspects that we would like to people to really understand those atoms. We would like to make sure that it fits in the law, and when we would like to make sure that we not get sued when people get any problem with that. So that's why it's hard to understand, hard to read, and because it's not designed for reading and understanding. And of course, it's frequently update and revision according to the feedback from market participants and according to the needs of the dynamic of the electricity grid. And for the clients of this chatbot, we have three parties. First of all, it's going to be the market participants who wants to understand the market mechanism of ISO and RTO. And of course, as I said, that is hard to understand. Those documentation are hard to read and hard to understand. So by leveraging those large language model, we're kind of distillation of those hard to understand items, so that to make people easily understand what is going on over there. And of course, the second party is going to be the employees at ISO and RTO who need to clarify and understand the regulatory details of the market in their daily work, such as some people like me. So, and of course, the third one is going to the public audience who is interested in how the electricity market is operated in each individual ISO and RTOs. So that's the clients of this chatbot. And next page, please. And the solution is that we're going to leverage this REC system. So in this REC system, the data we have is the nodal documentation. But it's worth to note that those nodal documentation is a base documentation that because it's open to public and it's easy to be accessed. But for each client, we can have our own database. Like for my company, or for employee in my company, so we can have our own database. Well, for the market participants, they have their own database that they can leverage those database to do this kind of REC system. So for the nodal documentation we use here is just a baseline of this REC system, and because it's kind of a mature technique for the application of large language model, but we do identify a couple of issues over here, such as the figure and table and formula processing. So that is a pretty challenge in the data processing stage. And because of the domain specific knowledge, it can introduce some challenge in the word embedding and tokenization when we do the indexing, when we do the when we feed it into a large language model, and when we generate a response. And of course, for the large language model, for each company, they have their own budget, and the high cost of API call from the advanced large language model is going to be an issue. And of course, the latency of hosting an open source model locally is going to be another issue that is hard for us to is another challenge that we're going to facing when we want to deploy this REC system that we design or we developed in our company. So that's the challenge we have identified. And with that, I'll pass it to Jane.
Yes.
Yeah, let me just yeah, this is probably repeat what Jennifer was saying, but this is a kind of screenshot of how the public document looks like. Okay. Next we go to Jane.
So yeah, since we have a lot of like a PDF documents and each document about hundreds of pages, so we just did some like exploration on like which tools can have best performance for like a text extraction or like a text extraction from like a scanned images or like a table extraction. So here I just like for everyone, like I summarize currently the popular tools for text extraction and information extraction from image in the middle column, and also table extraction. So I highlight the tools that I found which have best performance, and I will show you 2 examples. So next page. So here I just show you one of the paper which is related to my field. So this paper has 2 columns. I found basically the PyMu PDF, which shows the best performance. The reason I rank the best because you can tell from extraction, this tool can extract special characters like a delta and nanometer, like a degree C, something like that. And another advantage is like since this document is 2 column, if you go to the bottom of the left column, and the words where the sentence basically been divided in 2 sections, but this tool can make the connection or can recognize the words or sentence connection between the 2 columns. And also the format is quite nice. It shows you the page number and also shows the schemes and the figures at the bottom of the summary. So next page, please. And here I show you another example in this paper, which have tables. And the best tool is PDF Plumber, so which can extract the table information and summarize all the information in basically the data frame, pandas data frame format. So then in the future, if you want to extract information from the output, you can just go to the pandas data frame. Okay, that's all my part.
Thank you, Jen. Next is Lu and Junhao. Yeah.
Okay, yeah. So this is a RAG architecture. So basically the idea is using RAG, we can combine the LM with a domain-specific knowledge source, so can generate context-rich responses. So there is a flow chart. So basically the first step is we need to split the documents into chunks. Basically, like what we are using is PDF documents. So we split PDF documents into 1,000 tokens. So each chunk has 1,000 tokens, and there's also 100 token overlap. So we can maintain the context for each chunk of text. And then the next step is so the chunk steps will be embedded by the embedding model. So generate vectors. So store the embeddings in a vector database. So we are using a open source Chroma database for this demo. And then, so once we store the embeddings in the vector store, then we can use it for the chatbot. So we don't need to, generate embedding every time. So we just need to generate embedding once, and then the user. Once the LM receives the user input, so the embedding model will also embed the input query, and then retrieve the similar documents from the vector store, and then the context and the user query will be passed to the LM to generate a response. Okay, next page.
How do you deal with the table that you just mentioned?
Oh,
if it is a data frame.
right. That's the future work. So for now, we didn't specifically handle the tables. For tables, yeah, I think we should like read the table as a data frame and then generate key value pairs something.
Mm-hmm. How big is it? How big is the table typical? But usually it's pretty small, right?
Right.
I think one simple solution would be to describe it in natural language.
Do you like do you have any recommendation for the documents has tables? Do we do embedding where we just like filter the table information?
Yeah, I think you can use natural language to describe it for each row, right? Because it's usually one row is for a specific purpose.
Okay, so basically it's like a metadata again, right?
Right. But describe it in natural language. In that way, well, that is the simplest way to do it. But if you want to treat it in a more complex way and a more accurate way, then probably you need to use agent because you need to deal with the data frame, and you need to convert the natural language into a code to deal with the data frame.
Oh, just to get my understanding right, Kai. So that it's like you get those tables, you get them out, then use large language model to summarize it, and then put it back into the context. Is that?
Yeah.
Okay. Okay. Yeah.
Can you explain more about your second strategy with agent?
Yeah, that is using the coding ability, because that is basically an API, right? So you will build an agent. Because large language model has the agent ability, and it can call API. And then all you need to do is to teach your agent to how to correctly manipulate the API. And the API is basically a coding interpreter, and you can retrieve because you have a data frame, right? And
Yeah, so you mean the agent just need to understand the data frame, right?
yeah.
Okay.
You can provide it with the schema, and then you
Alright.
understand the data frame, and then
Okay.
you can make some code, and then you just use the Python interpreter to execute the code. Then you can get what you need, right? Because, for example, if you want to retrieve a certain column of a certain row, then that is basically data frame command, right? So
Yes.
you have dot add specific row and specific column. So all you need to do is to generate that line and then execute it in the interpreter. In that way, you can retrieve what is there, and it's 100% accurate.
Okay. Okay. So basically the agent receive the query and convert the query to a code, right?
Yeah. So that is the way to deal with this kind of data.
因为我前一阵儿学，应该是蓝城那上面的他给的那些 agent，就是做类似的东西，比如就是调一个这种 data frame，或者是数据库 SQL 里面的结果，让它去算，比如像平均值之类的，也是很简单的一些操作了。但是我当时注意到一个很明显的问题，就是它大语言模型它就不能够把整个数据全都读进去，因为他觉得太长了，所以他就经常只是读了前面的几十行，他就给出一个结果。
它是哪种方案？它是用那种把它变成convert into natural language，然后放到 prompt 里头呢，还是你给它一个 data frame？
他当时给的例子是，我记得是他直接给了一个这个 SQL database，然后用自然语言去问他，比如说某一列的平均值之类的，他返回的那个结果，这个数字是不对的，因为他只选取了前面的几十行去做计算，然后，但如果要让他出这个。SQL 命令的话是没有问题的，那个是对的。
对，有道理。
那相当于那个 SQL 的命令还是通过 ChatGPT 什么来生成的，是不是？
它是通过 agent 生成的，你要去调一个相当于会写 SQL 的一个 agent。
哦，现在是有这样的 agent 吗？还是自己写？
有啊。
还收费还有。
哦，叫啥呀？
就只是这个我就试的那个他这个问题就是像我说的那样，他这个数据他没法都给你跑完，他总是只取前面的一部分。那这样的话，这个结果还是不能用呀。
对的。
那老师是说有 其他更好的这种，比如写 code 的
我觉得
agent，还是说这是个普遍问题呢？
你如果它是用自然语言，那肯定会这样子呀。但是你如果是把它生成一个 SQL 命令的话，肯定准确度还是高很多。我觉得大语言模型本身你让它去算数，这个肯定不靠谱。
OK，而且它总是会有这个字数的限制哈。
对对对，尤其是现在有一些 long context 的这都是一些假 long context，它并不是真的有那么长的一个 context window。
我 offer 一个那个，我们最近学生做一个 project，就是 generative 这个 table 叫什么？GTL 就是用 GPT 来做那个 tabular 的那个 prediction。我不知道跟你这有没有关系啊，反正总之呢，最后就是也是有这个 context length 的问题。后来我就是说让学生你要不要把这个 data set chop 成，比如说10个小块儿。把它放进去，然后就做一个 agent，然后差不多10个小块做进去，然后最后再把它那个结果再把它 aggregate 一下，做出来结果还可以。
哎，好，有道理。Multi agent，哇，这档次一下子就上去了。好，那继续吧。
Okay, yeah, next slide. Yeah, so here we list some commonly used tools and technologies. So vector stores, so a very commonly used is a Pinecone, but this one is not an open source. So basically, if you need this for production purpose, you need to get API credentials to access Pinecone. So the remaining 3 choices are open source database. So basically, the second one is a Facebook AI similarity search. So this one is open source. It's a good choice. And also another one, Viviate. So this one is also open source database. So it's also good choice if we want to deploy the LM RAG chatbot locally, so we can have fully control. We don't need to rely on third party API. Also, a Chroma database is a lightweight open source vector database. So this one is very easy to use. And then for this project, we use this Chroma database for demo purpose. And then for the large language model, of course, there are also 2 options. One is the APIs. So we can call OpenAI GPT-4 mini or cloud model. So basically, these models are very, state of art. So basically, they're very good performance, but the cost may be high, and also we have to rely on those API for the service. And then because for many companies they worry about the data security and the data privacy, so maybe we can consider using open source models for this kind of project. So basically, for open source models, they are like Llama 3 or Mistral models. These are good choice, I think. So basically, for this project we tried the Llama 3.2. So there's a 3 billion it has 3 billion parameters, and then we can hold it locally on even on CPU. But of course, we know CPU is not suitable to run a large language model, so the latency is very long. And also we tried to host this Llama 3 on Google Colab, so using GPU to run it. So the latency is between 5 and 10 seconds. So basically, I think it's acceptable. But of course, Google Colab is not it's not suitable for production purpose. So if we deploy this on a cloud using GPU, I think it's a feasible choice. So it's a good choice for company if they worry about the data privacy. So we can use the open source model to build this product. And so for the UI, basically, for the project also we use the Streamlit to quickly build a UI for the chatbot interface. And then so for company, of course, we can integrate the chatbots into other portal, like also other websites for the company employees to use. And for deployment, so first we need to choose which platform we want to deploy the model to. So like if for production purpose, we need to use cloud providers like AWS, GPT, or Azure. Or for demo purpose, of course, we can hold the LM locally, but we should host it on GPU, not CPU. And for containerization, of course, we can use Docker to generate Docker image for scalability and portability. And for ML ops tools, yes, here they are. I asked ChatGPT. Basically, ChatGPT mentioned this TensorFlow serving, Torch serve, Fast API. Fast API is it's a great choice for lightweight product, basically, and also CI/CD. So for continuous updates. Okay, yeah, that's all.
Thank you, Lu. For evaluation, we used the ground truth as from a production chatbot in Jennifer's domain. Actually, a company built that chatbot. And Jennifer, do you want to cover the ground truth selections?
Oh, for the ground truth selections, I would like to divide it into 4 categories. So in order to test the different aspects of this RAG system. The first category is the comprehensive understanding part category. So that one is does not have any limitations on the response length of the response, so that we can let the chatbot generate as much as possible, or as much as it wants. And for the 200 word summary, we have 26 of those ground truths put out. So that is for the purpose of that testing some summary tasks. So because it's according to my own experience, most of the time I just want to know what is that, and that's it. So that is very helpful when I have a short summary of the terminology that I don't know. And for the simple retrieval part, and I just pull it from directly from something from the table of content, so that I can test whether the RAG system can identify the right chunk of that associated with those query. And for the mathematical formula part, I just like to test that how does this chatbot handling those mathematical formulas in the documentation, because we do have lots of mathematical formulas regarding how we settle the price of the electricity. So, but those I noticed that is pretty impressive that in the existing chatbot that we're referring to. So it has very good performance in identify those mathematical formula. So I was wondering that how do we do with that mathematical formula in our own RAG system? So that's the way that I choose those ground truth data sets. So go on.
Yeah, thanks, Jennifer. This part is from Jie. I think it's here. Oh, she said she's not here this day, so I'm gonna cover this. So for Ragus, there's quite a lot of metrics. One of the faithfulness is compare the response with the answers with the context you retrieved, and also the correctness, the similarities is compare the response with the ground truth, which we provide. Also, there's answer relevancies between the query and the response, as well as context recall, which compare the context with ground truth, which basically try to evaluate how well you retrieve the text, and also context precision compare with the query with the context. So this is 5 metrics. We did this based on the evaluation data set from Jennifer. So you can see it's actually getting pretty good precisions. You can see the distributions. Recall is okay, but not that good. That's reasonable. And the relevance is pretty good. You see the distribution. But compared to ground truth, it's kind of like around 0.5. It's reasonable, but it can be further improved. Which the ground truth answer is from the professional chatbot. And faithfulness response versus context is give a pretty good score. It means they summarize the context pretty well. It's our evaluation part. We also have an example, so trying to see, like, because we use the ChatGPT 4.0 model for the demo, so we want to see how good it is. If we don't provide the context versus context, you can see here without RAG, even though we specifically ask for mathematical formula, the ChatGPT cannot give the formula, but with the RAG, it was able to give the formula correctly. Means the retrieved document actually contributed to the answer. That's one example. Okay. Last part is a demo. As previous specified, we use a PyMU PDF, which perform best in terms of extract the PDF information. We did some text cleaning, remove the header, footers, all those unnecessary information, as well as different unrelated informations. We use the Chroma, which is the open source fast vector database. As Lu mentioned, we tried the Llama 3 as well as ChatGPT, the GPT-4o mini API. This one works, but the latency is very long. So for demo purpose, we use the GPT-4o mini. And web app, we use Streamlit. Yeah, I'll show the demo now. So this is the interface we have. So like here, ask a question. This is the ground truth from the professional chatbot. And this is the answer we have. And it also gives the documents which we compare. The page actually is correct with the context. And that means the metadata is pretty well preserved here. And also there's formulas. Let me just put some this formula here. You can see this is a professional chatbot's response. Just type. So you can see this one agrees well with ground truth.
How big is your database?
Database have about 1,500 chunks of 1,000 tokens. So
because I see it's pretty quick.
yeah, it's pretty quick. When in retrieving and as well as answer the question. Answer the question is due to the GPT-4 mini, but retrieving is also very fast. Like this one. Yeah, the speed is very fast. We tried Llama, it's just not as fast. So for demo purpose, we use this one. You can see it give you the source of data, the page, as well as the relevance score and real-time market. You see the 15-minute settlement interval compared to the ground truth. Here's this 15 minutes. I think I asked Jennifer says 15 minutes correct. Yeah, you see here. Because previous when we try Llama 3, sometimes give actually 5 minutes by retrieving other models, so it's not performing as good as GPT-4o. So that's some of the observation we have. The documents here, the document looks like mostly is text in bullet points. There's some small tables somewhere, but mostly text. Okay, that's this. They also have those temperature, basically 0 is more precise, 1 is more creative. So we default to text. Like this one, it's very easy to answer. If you ask about those nodal, because even though it's mentioned but doesn't make explained, it's not specifically explained in the document. So it will give you like this context does not explain nodal in the documents, but it does have a general knowledge within the GPT-4o refers so those market design. Basically, it's more detailed pricing and marketing operations instead of previous zoned operations. So it does give you that basically this means we didn't retrieve very good relevant information from the document, but this is answer from the GPT-4o. Yeah. That's the demo part. Then for future work, because like Lou mentioned, a lot of company we currently working at have a very sensitive. They don't want to outside API to obtain their internal documents. So that's why open source model may be a better option. But for latency purpose, we probably, if we use Llama model, even the smallest Llama model, we need to do some distillations to make it even faster, and also deploy it on the cloud using faster GPUs for better latency. That's all for our group. Any question, comments?
Yeah, very good. I'm really impressed with how you deal with the PDF and how you deal with the text. I don't know if you deal with the image or not, but probably not many images there, right?
Right. Jennifer can speak more about this. From what I see, I didn't see too many
Yeah,
images.
we don't have much many images over there, but we do
Oh.
have a couple of tables and a
Yeah.
lot of mathematical formulas.
That's very impressive. And also, I think you have done pretty good research on how to, on the engineering requirement for your solution. So I think that is really great. And for the metrics, that you have done a really great job. So nice work. Thank you.
Thanks, Kat. Yeah, let me stop sharing.
Any other questions?
I have a question. So for images, like what I have seen so far is like we can extract the 我就说中文吧，就我们可以从那个 image 里面提取那个文字的信息。我不知道张凯老师有没有知道其他的工具可以直接，比如说读一个 plot，然后去描述这个 plot 呀？
蒋老师要 comment 一下吗？
实际我工作当中也只是去读 image 当中的文字啦。另外就是工作之外的呢，学 Python 的时候，它里头它是用的，那个工具叫什么？就是把这个图片生成 embedding 非常常用的一个工具了。它那里面用那个，它举的例子是，比如像一个 Amazon 那样的网站，它有若干这个产品的图片，然后它也有一些文字叙述，然后你就可以用这个，它这个图片转 embedding 的这个工具去把 图片的部分做 embedding，然后文字的部分就用这个普通的这种 embedding 去做。搜索的时候可以这样联合搜索。当时我试着它的那个数据集，确实是加了图片的那种出来效果会更好。像你说的这种 plot，可能就是涉及到更加这种 scientific 方面的东西，对吧？像那些方面
对，
的我，
就像比如说什么 bar plot 那种线的图啊，就是如果说有一个工具能够直接把那个图读了，就给这个图做一个 summary。
这个东西好像是有包的，是有现成的一个，但是我现在不知道，你要是想的话，你可以私信我，我查一下。
好的，谢谢陈老师。
对 Cloud 的 multimodality 或者 ChatGPT 的 multimodality 应该也能，就是读出来这一个图，它的一些 summarization 了，理解这个图，然后给你 summarize 出来，因为它就是个 image to text 的嘛，就 image to text 的应该是现在做的比较好的模型，应该是挺多的。对，就像看图说话，看图说话这种模型是挺多的。比如说，也不用比如说了，Llama Meta 肯定会有很多的这种模型，然后你 ChatGPT Cloud 其实也能干这个事儿。OK，还有别的问题吗？好，那要是没有问题的话，我们就第3组。那耀文你们组可以开始讲吗？